Morning to everyone present here. Last class, as you already discussed, that the different effects of pressure, and we discussed about the increasing and decreasing pressure in the last class. So today, 17 February, 17 December, we are going to discuss liquid pressure. What is exactly liquid pressure, and to understand and analyze the pressure exerted by the liquids and applications of the liquid pressure. The pressure exerted by a stationary liquid means any liquid which is kept in a particular container. Any liquid. Now suppose if I bring a water bottle and if there is liquid in it, that exerts pressure. The pressure exerted by stationary liquid kept in a container at any point is known as liquid pressure, or it is called hydrostatic pressure. The liquid pushes on every surface in contact, no matter whichever the surface is facing. So if I take a bottle of water and the liquid is inside the bottle and it is exerting pressure on that particular bottle. So hence today we are going to start the pressure exerted by liquids. So here is a diagram to make you people understand. There are 4 diagrams. You can see a rubber balloon fitted at the end. So liquid's pressure on the bottom of the container does not depend on the area. Okay, means whatever is the surface, it will not depend on the area. It will depend directly perpendicularly. It will depend on it acts perpendicular to the base like this. You can see the balloon which is on the top of that particular bottle. You can see the balloon there. That balloon is inflated, which means that liquid is exerting pressure on the balloon. So liquid's pressure at any point inside the liquid depends on the density. If the density is more, then the liquid will exert more pressure. And the height is more, because liquid is exerting pressure below. If the height is more, then it will exert pressure below. So more the height, more is the pressure exerted. Less the height, less is the pressure exerted. So it doesn't depend on the shape, it depends on the height and the density. And in the last diagram, you can see liquids exert pressure on the sideways, because suppose if I take a bottle of water and if I put holes in it, the water gushes out with speed, which means the liquid is exerting pressure on the walls of the bottle. That is the proof. So this is an activity. Okay, this is an activity where you have to prove that liquid exerts pressure on the walls of the container. So this activity is in the book. If you study the activity, I will be asking this activity in the subsequent classes again. Last time you were not able to answer properly, so you have to study nicely this time. Then you have pressure increases with depth. This thing I guess you have done earlier. There is a container of liquid and a hole is made at different heights. You can see a hole is made at different heights. The hole which is below at the bottom, the water goes out to the farthest position. The water goes out to the farthest position, which means water is exerting more pressure below than at the top. So with the increase in depth means the deepness, the pressure increases. With the increase in depth, the pressure increases. So as a result, you can see the water from the top of the hole falls nearby to the container. The middle one falls a little bit far and the lower one falls extremely far, which means with the increase in height or the increase in depth, the pressure is more. Why depth? The below hole is having more height of the water, so the height is more for the hole at the below. That's why the pressure is more. Hence, we can say that the deeper into a liquid you go, the greater the weight of the liquid, which means divers or swimmers, when they go inside the ocean, very deep inside the ocean, then they feel the pressure of the liquid. Then you have pressure depends on the density. You can see a diagram where oil is also there, water is also there. Same height you have punched, the hole you have punched on the same height. Now you will see that water is flowing out at a higher speed than oil, which means water's density is, oil is lighter than oil. Oil is lighter than water. Temperature of oil is less than that of water. That's why oil floats on water. So oil has a less density. Since oil has a less density, what happens? It exerts less pressure. So it falls nearby. Whereas water has a more density, it exerts more pressure, falls further. So pressure depends on the density of the liquid. The more dense the liquid, the higher the pressure at any particular depth. Next, pressure does not depend on the shape of the container. Remember, as I told you, pressure depth depends on the height and the base where it is exerting. It does not depend on the shape. Any shape you take, pressure is the same. Next comes atmospheric pressure. Now I am sitting in a room. Pressure exerted by the atmosphere is called atmospheric pressure. Simple. So atmospheric pressure is the pressure of air around us, and it is due to the weight of the air. So the weight of the air column of a height of the atmosphere of area, this is as large as 1000 kg. So whatever we are facing, whatever pressure we are facing, there is the atmospheric pressure. And one column has that much pressure as the pressure exerted by a mass of 1000 kg. Just a comparison I am telling. So this is the concept of atmospheric pressure. The pressure exerted by atmosphere around us is the atmospheric pressure. What is atmosphere? The envelope of air around us is the atmosphere. So atmosphere is the layer of air enveloping the earth, and it extends up to 1000 km above the surface, and total mass of this much kg. The pressure inside our bodies is almost the same. Means the pressure that is given our bodies is almost the same as the external pressures. So our body balances it. We don't fall to the ground. Because the pressure we are getting from outside, the pressure we are giving from inside, that is same. So as a result, we don't fall to the ground. And at high altitudes, point number 3, which is very important, at high altitudes, the pressure is lower. Since the pressure is lower, the breathing is difficult. So nose bleeding occurs as a result from the pressure difference between the body and the external pressure. Because at higher altitude, if you go, the pressure is less. Because our body is giving more pressure. So there is a difference in pressure. Our body cannot balance that. So nose bleeding is very common. Atmospheric pressure, you can see the diagram. When the piston is pulled up, the atmospheric pressure inside the cylinder will decrease. Because when you push a cylinder, inside the cylinder, it decreases. So the atmospheric pressure outside pushes the liquid up into the syringe. Because when we draw water into the syringe, the inside pressure decreases, and outside atmospheric pressure pushes the liquid to go inside the syringe. This is an example of atmospheric pressure I am talking about. Then you have straw, same phenomena. When a person sucks through a straw, we are sucking through a straw, the pressure in the straw becomes low because you are sucking it, you are taking out the air outside. The atmospheric pressure outside, which is higher than the pressure inside the straw, because when we suck, the pressure inside becomes low. As a result, pressure from outside pushes the water into the straw, and then we can drink it. So syringe, then straw, these are all examples of atmospheric pressure. Hence, then we have vacuum cleaner. You can see the vacuum cleaner, air is going outside, dust is coming inside. When a vacuum cleaner is switched on, it sucks the air inside the cleaner, causes the pressure inside the cleaner becomes low because it is sucking air. It is sucking air. The atmospheric pressure again, which is higher, pushes the dust particles into the vacuum cleaner. As simple as that. The same phenomenon function is same. Whenever you suck something, you decrease the pressure, and the atmospheric pressure pushes the thing inside it, and it is being taken. So thank you everyone. That was the chapter that today we discussed. We discussed about vacuum cleaner, syringe, straw, atmospheric pressure. Then we discussed about, it doesn't depend on the shape of the container. It depends on the density. Then it increases with depth exerted by liquids. This is a small question for you. Ravi's grandfather, whenever he goes to hill station, he observes a very common phenomenon of nose bleeding. Whenever Ravi's father or grandfather visits hill station, they have nose bleeding. What is the reason behind that? That is the question for today's class. So that's for today. As liquid pressure. So all of you please go through this video properly to answer me in the next class. As you always know, again if you don't answer in the next class, your one more class is gone. So now it depends on you how much you answer and how much you study. Thank you very much students. Stay safe, stay blessed and study properly. Thank you.